A warm welcome to everyone. Our project is Cloud Truth, a combined project of AWG and Smart Irrigation System. Introduction. This project combines two systems. Atmospheric water generator, AWG, it collects water from humidity present in air. Smart irrigation system, it uses water to dry soil. Together, they save water and support sustainable farming in the objectives. Our objective is to collect water from air moisture using AWG fan. AWG fan absorbs the air and the Peltier module creates the temperature difference and heat sink produces the water. Components required are Arduino Uno, soil moisture sensor. Soil moisture sensor measures the electrical resistance between the two probes which depend on the soil moisture level. Relay module. Relay module, it is a single channeled module and it's specifically modeled as HW307 water pump or DC motor. An AWG fan unit which contains Peltier module, AWG fan and a heat sink, water tank connecting wires, 12-volt power supply. Working principle of AWG. The AWG fan absorbs the air from the environment. Peltier module creates the temperature diff with the help of heat sink. It cools the air, condenses the water vapor present in air. The condensed water is stored in provides pure water for irrigation. Smart irrigation system. The soil moisture sensor detects the dryness of the soil. When the soil is dry, Arduino signals to the relay module. The relay activates the pump. Water is automatically pumped from tank to soil. When the soil becomes wet, the Arduino turns off the pump. Circuit explanation. AWG Peltier module is sandwiched between the heatsink and fan with the help of thermal grease. Thermal grease is added to increase the conductivity. Soil moisture sensor is connected to Arduino using an analog pin. The relay is connected using a digital pin. The motor connects to the relay to control the water flow. Arduino controls the relay based on the soil moisture readings. Let's view the working demo of our project. The collected water stored in the tank and it can be filtered and used. Unfiltered water can be used for irrigation.
Now the Arduino board is the brain of our system.
It is connected to the soil moisture sensor. The water pump and relay module.
The soil moisture sensor is placed in the soil to check whether the soil is dry or wet.
If the soil becomes dry, the sensor sends the signal to Arduino.
The Arduino then turns on the water pump and the water collected from the AWG is sprayed on the field. The soil moisture sensor and Arduino is now switched on. Now the soil moisture sensor is inserted to a stand. Now the sand becomes wet. Now the soil moisture sensor sends a signal to the Arduino. The Arduino stops the motor.
Have you seen it? The collected water stored. Advantages of our project. It is fully automatic water management. It also saves the water and energy. It produces water from air. It doesn't need a water source and it also uses water when only it is needed. It can be used in the arid areas and dry areas where water is limited. Applications. It can be used on small scale farms in agriculture farming. and even on gardens and home plants and greenhouses. In greenhouses, the transpirated water by plant can be converted back into water vapor and planted to water to plants. And it can be also used in remote areas with low water sources. Future scope. We can add IoT for remote monitoring, using solar power for full ecosystem, enhancing AWG efficiency for large scale. Conclusion. A small irrigation system using AWG is a self-contained, localized system that harvests moisture from ambient air and directs it to irrigate crops on a small-scale farm. This technology provides a reliable, decentralized, environmentally sustainable water